I'm going to do things a little bit differently. I'm going to give you two of the trig functions in here, two of the trig functions. But instead of making a triangle, I'm going to ask you to do it by using the identities. Okay, so I'm gonna give you two trig functions. So I'm given, so number 2, given tangent theta, tangent of pi over 4 is equals to 1, and sine pi over 4 equals to root 2 over 2. Find the rest by using only identities. Okay, so I want you to find the rest by using only identities. And how do we do this kind of approach in here? First of all, if we can find a sine and cosine and we have the tangent, the rest of them is just the reciprocal. Okay, if you're not quite sure what I'm talking about, you can go back and take a look at the identities I provided. Okay, so the main challenge in here is how can we find the cosine? Okay, and luckily we do have a formula to do it, which is tangent of theta is equals to sine of theta over cosine of theta. Okay, so that is one of the identities we provided. So if we just plug in all those numbers we already get, and we should be able to solve cosine theta. So that is tangent pi over 4 equals to sine pi over 4 divided by cosine pi over 4. So in this step, I'm just substituting all the thetas into pi over 4. And because we are dealing with the theta, it's actually equals to pi over 4. So with that, and then we can substitute the value, which is equals to 1, equals to root 2 over 2 divided by cosine pi over 4. Okay. So the next step is we just multiply the cosine pi over 4 into another side, and we got cosine pi over 4 times 1, which is still just pi over 4, cosine pi over 4, and equals to root 2 over 2. And we're done. And look at that. We got the cosine pi over 4 is set up. So from here, we have cosine pi over 4. We have sine pi over 4, which is equals to root 2 over 2. And we also have tangent pi over 4, which is 1. Okay, so from here, after you got those 3 main trig functions, and we should be easily to find out what's the rest of them. Okay, because the rest of them is just the reciprocal of them. Okay, so let's take a look at how we do that. So the way how we're doing it is we just go from here, and that will be the secant pi over 4. And we just flip this number, so that's 2 root 2, which is equals to root 2. Okay, if you do a little bit of simplify. Same thing, from here, we can get the cosecant pi over 4. That is equals to the reciprocal of the sines, also the same thing, 2 root 2 equals to root 2. Okay, so we got that one, it's taken care of too. And then lastly, we can get the cotangent of pi over 4. That is the reciprocal of 1, which is still 1. Okay. So from here, we got all these nice things set up and perfectly. Okay. So from here, after you got cosine, sine, and tangent, we can get the rest of 3 very easily. Okay. So this is another method on how to do things. And if you like this method, keep doing this way. But if you prefer the triangle methods, do the triangle way. Okay. And there is another topic I really like to cover it in today's lecture. It's called the cofunctions. So this is now an example. It's a cofunction. Okay, what is a cofunctions? So before I'm making a cofunctions, I like to give you guys the right triangles right here. So if I have an alpha, it's also just a name for the angle, and I have a beta, also the name of the function, and I have a 90 degrees in here. As you can see from these triangles in here, we know alpha plus beta is equals to 90 degree or equals to pi over 2, right? So it depends how you want to write it. It's either a degree or radian, kind of writing notations, okay? And so to write trying to write the cofunctions, it's going to be, if I'm writing a sine of beta, it's going to be a cosine of alpha. Okay, so if I'm doing a sine of beta, which is right here, which is the same as doing a cosine of alpha right here. Okay. The same thing, there's another pair, it's the tangent of beta. It's equals to the cotangent of the alpha. And later on, we have our third one, which is the cosecant of beta equals to the secant of alpha. Okay. So as you can see from this relationship in here, alpha and beta has to be with the adding together as a 90 degree. Okay. If they do have their relationships like that, and this kind of formula is worked out. And this kind of formula is called the cofunction formula. Okay. All right. So from here, let me give you guys a few examples, and hopefully that can help you guys out a bit. Okay. So the first one of the example is if I have a sine pi over 6, which is equals to 1/2, and from here, and pi over 6 with another angle will be pi over 3. So that gives you cosine of pi over 3. It should be also equals to 1/2. Okay. So from here, and then you can see the relationship because the pi over 6 plus pi over 3 equals to pi over 2, which is the 90 degree. Okay. So they added together is a 90 degree, and we're good to go. Second one, if I tell you there's a cotangent 64 degree, and what should this one equals to? And you should be automatically thinking about, oh, what's another degree we're adding in here and gets to 90? And that gives you another hint in here is 90 degrees subtracting the 64 degree, that gives you 26 degree. So we have a tangent, which is 26 degrees. Okay. And then we got this figured out. So the cofunction itself is actually not that very difficult, but they're actually really useful for us when we're coming into memorizing the unit circles and stuff like that. And that will come handy in the next section. We're talking about the unit circle, and you guys need to start memorizing for the unit circle. Okay. Okay. So after when we talk about all the trig functions and nice things like that, and I would really like to give you guys a word problem. And don't be panicked. Okay. The word problem is not going to be really hard, but it will shows you how it's the trig function is going to do with this entire things in here. Okay, so what I'm going to give you the word problem is, okay, I have so this is an example. I have a very nice sun in here. Okay, all right, and there is a tree just nicely landed on the ground right here. Okay. Okay. And in some points on the day, the sun is actually has a 40-degree to the ground. So I have a 40-degree and to the ground in here. Okay. And luckily, we hit the tree in here and gives a very nice shadow. So that is the shadow, and that is created by the sun. Okay. And this nice shadow in here, we can measure it. This shadow is actually 35 feet long from the tree. Okay. So here's my question. My question is, how tall is the tree? Okay. So with all these ideas we are giving in here, how tall is the tree? Okay. And if you need to do this one, we need to round it to the integer. Okay. So we don't want any decimals and stuff like that. Okay. So another way to see these things is you can put this graph into a very beautiful, nice right triangle. Since the tree has to be straight up from the ground, so we can have this one is 35 and this one is 40. Okay, so we're looking for this length in here. Okay. So if you really think about it, the relationship, and then you check your formulas and see how these things work, and you should be able to find out. So let's assume this is a height. Let's give a letter H. Okay, so we want to find H. How do we find something in here? And we look at all the trigonometry functions, and we find out, oh, actually tangent can find the relations between these two lengths, which gives us tangent of 40 degree equals to H over 35. Okay. So after we find that, we just need to multiply 35 from both sides. And then we can have this one cancel. So after the ones cancel, we get into our formula, which is H equals to 35 times tangent of 40 degree. Okay. And if you put that in your calculator, and make sure when you put in your calculator, you make sure the mole, it has to be on degree, not radian. Okay. After you do the calculation, we can round this one to the nearest integer, so that gives us 29 feet. Okay. Make sure you have the units attached to it. So it gives us 29 feet. Okay. So from this word problems in here, and you can see trigonometry is actually around all our worlds. And that comes very handy when it has anything with an angle or triangle and stuff like that. Okay. And you don't actually have to climb the tree to find out the height. And you can just use the trig functions to sort it out. Okay. For more of this stuff, we'll continue on the next time. Okay. I'll see you next video.